Okay, so let's go through this equilibrium calculation example. We have our reaction just given to us, so that's easy. Then for this reaction, K is equal to Q. I'll just write that down over here. K is Q, and that's going to be equal to, we're given K is 0.578 is equal to, what's Q? Cl squared over Cl2. Then the ice table. Here's our ice table. We have a Kp, so this is going to all be in atmospheres. So my initial Cl2 is 5.0 minus x, 0 plus 2x. Remember, I've got that coefficient of 2 there. And then my final is 5.0 minus x and 2x. Then I plug back into K equals Q, and I get 0.578 is equal to 2x, that whole thing squared, over 5.0 minus x. Then we get to the real chemistry here, is just thinking about what method do we want to use to solve this. So again, remember, we can only use our approximation if K is small. So yeah, remember here, if K is really small, approximation is usually going to work. In this case, K is moderately sized or close to 1. So it's hard to say. It's probably not going to be quite small for x. So we probably need to use one of our other methods, like the quadratic or equation solver. I'll show both of those here. First, I'll show the quadratic and then the equation solver method. So remember, for the quadratic, we want to get everything over to one side here to make this as easy as possible to solve. So first thing I'll do is I'll multiply both sides by 5.0 minus x. That's going to get me 0.578 times 5.0 minus x is equal to the quantity 2x squared here. I'm just going to expand this right now. That gives me 4x squared. Remember that 2 has to get applied to the 2 here. So this is 2 squared is 4 times x squared. Then again, I'm just going to save myself, I don't know. Well, here, we can do it either way. You just multiply this out. I guess that's not too much work. Then I'm going to get, so when I do that distributing, I get 2.89 minus 0.578x is equal to 4x squared. Then I'll just move everything over to this side with the x squared. So I get 0 is equal to 4x squared plus 0.578x minus 2.89. And this is now how I want it. I've got A is 4, B is 0.578, and C is negative 2.89. And then I can just use negative x is equal to negative b over 2a plus and minus b squared minus 4ac. So then we check our answer. In this case, that first value of x, which is negative, my concentration of Cl is going to be negative 2 times that, an even bigger negative number. So that's going to be, so based on that, we can then say x has to be the 0.78. That'll give us both positive concentrations, and that's then our final answer here. So Cl is going to be 2 times that. So yeah, when I plug in and round to just 2 significant figures, I get 1.6 atmospheres for the partial pressure of Cl here, and 4.2 atmospheres for Cl2. Okay, so here's an example using Solver. I have my equation here, and then I just go into Solver, so math. Oops, I got to turn it on. Math, up, Solver. Now I go up to the equation, and I'm going to type my equation in. In this case, it's, remember I have to rearrange this so it's all on one side. So I'm just going to subtract 0.578 from both sides and do 2x squared over, now this thing is all in the denominator, so that needs to be in parentheses, over 5.0 minus x. This is here, and then I'm subtracting 0.578 from both sides, so minus
0.578. That's my equation. Now I press enter to go back down here to my x. I always like to guess 0 to start with. If you have another number in there, I always like to just first guess 0. Then I go in and do alpha, enter to get to that solve option. So that will solve. And in this case, it spat out 0.78. Remember, you need to, just like the quadratic, you need to double check that this will actually work. So my value is 0.78. I have to plug that into the equilibrium row of the ICE table. When I do that, I get 4.2 for the concentration of Cl2 and 1.6 for the concentration of Cl. So that is all okay. All my concentrations are positive, and that is the correct value of X. Remember, you still need to, if you're using solver, need to check that all your concentrations are positive.